Hello everyone, welcome back to the channel. Today we are going to crack an interview favorite coding problem, that is best time to buy and sell stock, which is there on LeetCode itself. So basically, imagine you are tracking the stock prices daily and you can buy on one day and we can sell on a later day. So basically how we used to maximize our profit. That is basically the problem statement. Let's go through a problem statement to understand it with an example. We have been given an array prices where prices says I is the price of a given stock on the ith day, okay? And we want to maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock, okay? And we have to return the maximum profit that we can achieve from this transaction. If we can't achieve any profit, we have to return 0. So basically, let's go through the example. And what it says is basically, we have been given an array of prices 7, 1, 5, 3, 6, 4, and we have to check on which 2 day, like when we have to buy and when we have to sell, so that our profit gets maximized. So basically, here we can see that if we buy on first index, that is 1, and we can sell on the second, third, fourth index, that is 6, and then we can subtract it, so the output will become 6 minus 1, that is 5. So basically this approach we have to use. And let's understand the problem and like what will be the intuition of making a brute force approach. So we have been given a array containing 6 elements, and the basic naive approach should be like we can buy first and sell later, and we also have to keep in mind like no short selling allowed. So basically the first approach is, I will show you, that was a brute force approach. Yeah, so that is brute force approach. And the first approach is very quite straightforward, like we have to try all possible buy and sell pairs. Okay, so I have a question for you guys, like how would you solve this if I asked you to manually check all the possibilities? So alright, so basically we will iterate over all possible days to buy I. Okay, in the price array we have to iterate over all possible days to buy I. For each I, we have to check all possible days to sell, and the condition should be like j should be greater than I, because we have to return the profit. Okay, so we have to compute the profit, that will be prices of j minus prices of I, and then we need to keep track of the maximum profit found. So basically let's understand with an example table, then we will be referring the code above. So basically I will be the buy day and the j will be the sell day, and the profit we need to calculate is through subtracting the price of j with price of I. So from day 1 we can see like the array element was 7 and the day 2 was 1. So if we subtract 1 from 7, the answer we will get will be minus 6. Since the answer is a negative, we will not be taking this, we will be straight away discarding this, and we will reset it to 0. And again at day 1 we are getting like 7 only, and we are subtracting it through 5. Okay, then also we are getting negative solution. Again we are not going to take this solution, we are not storing this because it's a negative value. Again we are checking for day 1 7 and the day 4 3. Again we are getting negative value. Then from day 2 we are getting 1 and day 3 we are getting 5. If we subtract this, we are getting 4. So that is acceptable because it's a positive solution. But after that also we will keep updating ourselves to the next indexes in order to check the maximum profit. So we will check with day 2 1, then with day 5 6, that will be 6, and the subtracted values will be 6 minus 1, that will give us 5. So the maximum profit will become 5. But guys, let's understand what's the problem with the brute force approach through the code. So basically we have been given a function. We are putting the parameter of array prices, vector of array, f vector prices, and we are initiating the maximum profit will be 0. That will store the maximum profit. And for getting that, for buying it every day, we need to traverse a loop in the prices array that we get in the input, and we have to keep incrementing it, and we have to check the selling day also. So for this we need to add one nested loop that will give us the selling day, and the condition will be like it will be starting from one value after the I, and it will keep traversing till the size of the price array. And the profit, as we discussed before, the profit value will be like we need to subtract from the j, the I value we need to subtract from j, so in order to calculate profit. So it is obvious that if the price of j is smaller than price of I, that will give us the negative value. We won't be taking that. So for keep tracking of that part, we have created a max profit, and we are giving a max function. So in this we will be taking max profit or an profit value. Whichever thing is bigger, we will update max profit with the better one, and after all the things we will return the max profit. So basically this approach is I'm damn sure like it will be taking like of n square solution time complexity, because the two for loops are there and one is nested for loop. So definitely the time complexity will be of n square and nested loop. So for very large inputs, it will be very slow solution. So the interviewer will not be happy with this approach. So we need to think something better. Okay, and the time space complexity is constant as we are not using any extra space. So we need to think a better approach which will be reducing the time of the solution basically. So my question is how to think optimally, right? So let's step back and rethink our approach. What we were doing in the brute force was we were checking all the pairs, right? But what if we could keep track of the lowest price while scanning through the array? Okay, so what we have to do is basically we only need one pass through the array. So what we have to do is, if we keep track of the lowest buying prices so far, so we can instantly check the best profit at each step, and the formula will remain same for profit, that is current price minus the minimum price seen so far. Okay, so does this make sense? So we will discuss it. We will discuss it with the table, along with the taking the table and an example. So let's go through an optimal approach. What I'm trying to say is basically, if we keep track of the lowest buying price so far, we can instantly check the best price at each step. That's what I said. And the profit formula will be like current price minus the minimum price seen so far. So let's go with an example, and we will dry run that. So minimum price, we are taking a variable minimum price that will be the smallest price seen so far, and the max profit will be the highest profit found. So the day one, these are the days, these are the prices, and this is the minimum price so far. We will keep updating it, and the maximum prices so far. Okay, so since let's go through the table and let's understand it deeply. So in the first day, the price of I is 7 and the minimum price is 7 only. So the profit will be like price of I minus the minimum price. So 7 minus 7 we will get 0, and the maximum profit also we will get 0. In the second day, the price of I is 1 and the minimum price is 1 only, but the profit will remain 0 as 1 minus 1 will be 0 itself, and the maximum profit is also 0. From the third day, we are getting the price of I is 5 and the lowest price so far is 1. That is, we have done in the previous one. And we will calculate the profit value, that will be 5 minus 1, and it will give us as 4. So the maximum profit will be updated to 4. And similarly, in case of day 4, the price of I is 3 and lowest price so far is 1, and the profit is basically 3 minus 1 is 2, and the maximum profit, which was the 4, will remain same as 2 is smaller than 4. In the next day, that is day 5, the price of I is 6 and the lowest price so far is 1. So we will subtract it, we will get it 6 minus 1 is equals to 5, and the maximum profit will be 5. So basically, at the 6th day also, the price of I will be 4 and the lowest price will be 1, and we will keep on subtracting it, we will get 5. So the maximum profit we get is 5. So if we buy at rupees 1 and we will sell at rupees 6, we will get the maximum profit. Let's go through the LeetCode interface and try to visualize the solution. So basically, we are having the max profit function, and we are initiating a min price variable, and we are initiating with the int max value that will store the minimum price found so far, and we are also initiating the max profit value, that is 0. We are storing the maximum profit found here, and we are traversing the price array. We are updating the minimum price if a lower price is found through the min function, and we are also adding the formula for profit, how we are calculating the profit if we sell at current day, and the max profit will become the max profit and profit value, and we will update the max profit if it is the highest so far, and we will return the max profit. This will be our answer. So basically, we can see like the time complexity for this approach will be O of n only, because we are using single pass through the array, which will be fast enough, and the space complexity will be constant. We are not using any extra space. So this is the optimal approach which the interviewer will like. So if you like the solution and approach, and you understood the solution, please hit the like button and share it with the other students as well. Thank you.